Welcome to Math with Father. Welcome to Math with Father. Subscribe, like and share.
Class, in this video, we are going to learn about indices, the explanation of indices, the laws of indices, and the properties on indices. So let's delve right into this. Now, indices simply means the repetition of numbers or the repeated multiplication of numbers. Example, 2 times 2 times 2 times 2 times 2. So the number 2 repeats itself 1, 2, 3, 4, 5. And the simple way of writing the repetition of this number 2 is taking one of them and then counting the number of 2 that we have over here. So we have 5 of the 2's and the number 5 is written on top of the 2. Now, the number 2 here means the base. The number 5, which is on top of the 2, means the index or power or exponent. Now, numbers can be expressed in the index form or index notation, which simply means simplifying huge numbers or simplifying repetition of numbers. Example, expressing these in an index form. So the first one, we have 7 multiplying itself 1, 2, 3, 4, 5, 6. Now 7 is written as the base, and the number of times it keeps on repeating is also 6. So 6 is written on top of it as the exponent or index. Now let's move on to the second one. We have y repeating itself 4 times. 1, 2, 3, 4. So we have y repeating itself 4 times. So this is also the index form of the repetition of y. The next one, we have 10 repeating itself 1, 2, 3, 4, 5. So we have 10 repeating itself 5 times. The next one, we have the decimal 4.5, 4.5, 4.5, 4.5. 4 of the 4.5s repeating itself 4 times. To the power 4. The next one, we have half repeating itself 1, 2, 3, 4, 5, 6. So half repeating itself 6 times. So this is the simplest way of writing these numbers, and what we have over here as our results are in the index form. We are moving on to the laws of indices. There are 3 basic laws. Now the first law, called the product law. The second law, called the quotient law, and the third law, called the power law. So with the product law, it says a number raised to a power. So we have the expression a to the power m by a to the power n. So the product law states if a number or an expression in an index form multiplies another expression in an index form with the same base, then the base, which is a, the base, which is a, is raised to the power their index, which is n, and the operation between the index is plus. So this is all about the product law. With the quotient law, we have the same index form, but the operational sign in between them is division. And simplifying this, we have a m. The operational sign, which is division, makes the index or exponent differs. So we have a to the power m minus n, and this is the quotient law. The last one, power law, we have a to the power m multiplying another power n, and this is being expressed as a to the power n multiplying n, and this can also be written as a to the power m n. So these are the three basic laws of indices. Now let's delve right into some illustrative examples under the laws. The first law, examples on or under the first law. Now we have 5 to the power 1 multiplying 5 to the power 2. So the first law states that if the bases are the same, which is 5, then we add up their exponents. So we have 1 plus 2. So this gives us 5 to the power 3. We have x as the base, we have 2 as the power, multiplying another x as a base and 3 as the power. So x is now taken as our base and the powers are summed up. X to the power 5. Now the last one, we have this expression multiplying this expression, and we have rational numbers which are 2 and then 4. So these coefficients multiply and then we have 8. Now we have x as a base, we have at the same another x, we have y, we have y. So one x is picked, and since the operational sign here is multiplication, we have 4 plus into brackets minus 2 y minus 3 plus 6, and this yields x 8 x 4 plus minus 2, which is 4 minus 2, and then it gives us 2, and y minus 3 plus 6 gives us y 3. Now these are the examples under the first law. Let's move on to examples on the second law with the same preamble. Examples on law 2. Law 2. Where we have 5 as a base to the power 4 dividing 5 to the power 2. So the bases are 5, 5 is selected, and the operational sign between these two indexes or indices is division. So we have 4 minus 2, and this gives us 5 to the power 2. 4 minus 2 gives us 2. We have x as a base, and to the power 5 minus 2, which gives us x to the power 3. Now on the last one, we have 4 x to the power 4 y to the power negative 3, all dividing x to x to the power 2 y to the power negative 3. So we divide the coefficient, which is 4 divided by 2, and then multiplying x to the power 4 minus 2. So we have x to the power 4, we have x to the power 2. So x is picked, and since the operation is division, we have 4 minus 2. So we have y to the power minus 3 minus, into brackets, minus 3. Now 4 divided by 2 gives us 2. We have x, 2, y, we have minus 3 minus 3, what is it? Minus 3 plus 3. And our result is 2x squared y minus 3 plus 3 gives us y 0. And y0 is an identity, or is a property which would be explained earlier. Y to the power 0 is equal to 1, which is 2x squared by 1 still gives us 2x squared. So this is the simplified form of these indexes or indices under the second law. Illustrative examples on the third law. So let's delve right into these examples under the third law. So the first one, we have x squared multiplied 4, x squared multiplied, so the powers are now multiplied, and the result is x to the power 8. So 4 times 2 or 2 times 2 gives us 8. The next one, we have 3 by 2 times 3 equals 3. 2 times 3 also gives us 6. The last one, we have 2 to the power negative 2, x to the power 4 times negative 2, y to the power 3 times negative 2. We have 2 negative 2, x to the power negative 8, y to the power negative 6. So these are also examples under the power law. Properties of indices. The first property, called the zero index. So it states any number raised to the power 0 is 1. So a raised to the power 0, a raised to the power 0 is 1. So in an expression, a to the power n divided by a to the power n, where m is equal to n. So now with the powers, m is equal to n, and this can be used interchangeably. So this is also rewritten as a to the power m divided by a to the power n. So where m is equal to n is equal to a to the power m divided by a to the power m, which is now equal to a. So from the quotient law, it states if the bases are the same and the operation is division, we have m minus n, a to the power 0. And from the index property, which is the zero index, it says any number raised to the power 0 is 1. So am divides am, which is 1. So 1 is equal to am minus m, which is equal to a to the power 0 is equal to 1. So any number or any expression raised to the power 0 is 1 as our first property. Property 2. Index of product of two numbers. Now we have a, b, all raised to the power n. So similar to our third law, which was the power law, it says anytime we have a base raised to a power multiplying another power. So similar to this, we have a to the power n. So n is raised, or a is raised by n, b is also raised by n, b n. And this is a property called the index of product of two property. The index of product of two property. Example, another form, a x bx all raised to the power y. So the simplification or the simplified form of this expression is a x multiplied by y by b x also multiplied by y. A xy times b xy, a xy b xy. So this is also another property. The next property, negative index. Anytime we have a to the power negative 1, this is also rewritten as 1 on a to the power n. 1 on a to the power n. And this is called the negative index. So anytime you have 2 to the power negative 2, this is also rewritten as 1 on 2 to the power 2. It's given us 1 on 4. So this is also a property called the negative index. Next property, index of quotient of two numbers. Now a on b all raised to the power n. This is also simplified as a to the power n on b to the power n. This is the index of quotient of two numbers. Example, we have 2 on 3 all raised to the power 2. 2 raised to the power 2 on 3 raised to the power 3. And we have 4 all on 9. So this is also a property called index of quotient of two numbers. The next property, negative index of quotient of two numbers, a on b all raised to the power negative n. This is rewritten as a to the power negative n colon b to the power negative n. So from the negative index, we know a to the power negative n is also written as 1 on a to the power n. Similar to b to the power negative n, we have 1 on b to the power n. And we can express this as a to the power an. So the division now divided by 1 on b to the power n. So from our basic rules in multiplication, we know this is a to the power n times b to the power n on 1. n on a n. So this is also the negative index of quotient of two numbers. So anytime you come across this, the denominator, it reciprocates. So the denominator moves to the top and then the numerator also moves downwards. Next property, fractional index. Fractional index. Fractional index. Any number raised to the power a fraction as an index would be rewritten as, so we have a raised to the power half as the index. So this can be written as square root of a. Square root of a. Now the half, which acts as an index, means root, means square root. So the half, which acts as an index, it means the square root. Example, 81 raised to the power half is written as the square root of 81, and this gives us 9. We can also have a raised to the power 2 on 3. Now, to come out with a simpler or the simplest form of this, always the denominator of the fraction defines the root. The denominator of the fraction defines the root. So in this case, we have 3 as our root, and then it becomes the cube root. The cube root of a. The cube root of a, all multiplied by the numerator 2. So these are the properties of indices. So in my next video, we would solve examples on questions pertaining indices, how to use the laws, how to use the properties to disintegrate, bisect, and then dissect all indices questions. So thank you.